Hello everybody and welcome back to Elementary Statistics Online at Frederick Community College. In this video I will briefly go through main concepts of Chapter 5, some tricks to remember and maybe mistakes to avoid. So use this to prepare for your test. Okay, let's take a look at the first section that we've covered called random variable. Here we talked about probability distribution function for random variable, where we say x is a discrete variable, okay, and we're gonna have p of x is the probability of x happening, right? And we looked at tables where you have all your possible x's listed. And then for each x, you have a corresponding probability of that outcome happening, right? So a couple of rules to remember here is that, first of all, p of x has to be between 1 and 0 for each x, okay? It has to be a positive number between 0 and 1 for each x. And the second part that we need to remember, the summation of all probabilities has to be 1. Not close to 1, not just a little over or just a little under 1, exactly 1. Okay? So what would be an example of such a problem? Let's say you have numbers here 2, 4, 7, 9, and 10. I'm just randomly picking up these numbers, so these are my outcomes for x, whatever that might be. And then let's come up with a couple. So let's say 0.15 here, let's say 0.2 here. Let's see, what is this? That's already a half. And then 0.25. Okay, so that would be a probability distribution function, because each of the outcomes has a probability that's between 0 and 1, and if I add them all up, that will give me 1. You can check. Okay, those are the only rules that you need to check if something is a probability distribution function. So what type of problems can you come across? Let's go to your textbook and we'll take a look at the problem 48 on page 207. And here we have a survey of 827 people, and they were asked how many days they would wait before they go to a doctor if they were suffering from pain that interfered with their ability to work. Okay, so you have this table right here, and the days right here represent how many days you would wait, and then frequency, that's the number of people that responded with that number. Okay, before we start doing any computation, let's just try to picture ourselves in this situation. Okay, let's say I am suffering from pain. How many days would I wait? Well, I probably would wait at least one. So I see this number 436. Over half of the sample said we're gonna wait 1 day, and then a pretty large number said 2 days, and then the numbers go down. Okay, it looks like very few people said, oh, we're gonna wait 5 days, right? So make sure that you think about this problem before you start jumping to a calculator, right, and say, okay, do these numbers actually make sense? Okay, construct the probability distribution function. That's the first step in solving this problem. I'm gonna get my calculator here, and let's see, what does it mean? Let me show you. Okay, I'm going to plug in, go to stat edit, and in L1 I already have all my numbers plugged in. So these are my x values. That's the number of days people would wait before going to a doctor, 0 through 5, and then in L2 I have my frequencies. Okay, to construct the probability distribution of x, I need to find the probability of each event happening. So I need to take the frequency and divide by the total. There's an easy way of doing it. I'm going to go up here to L2, press enter, and do second L2 divide by the total, which is 827. And here they are. Here my probability. Okay, you can see them. They're all numbers between 0 and 1. Okay, you can always check if they add up to 1 if you go to second stat, scroll to math, press command 5, which is your summation, and we're gonna sum all numbers in L2, and it's 1. It's exactly what I want. Okay, so now I can answer the following questions. Find the probability that a person would wait for 3 days. So how would I write this? Okay, so I would write it like this. Probability that person is waiting for 3 days. And then I'm looking at my calculator. Let me go back here. And I'm gonna find my x value of 3, the corresponding probability. We're gonna do 4 decimal places. So what is it? 0.0871. Okay, 0.0871. Okay. Second question, or third question, find the probability that a person would wait more than 2 days. More than 2 days. More than 2. So that means x is equal to 3 or 4 or 5, right? Okay, so I can add up, let's see, where my calculator, add up these probabilities here, so 3, 4, and 5, and just add them up. Or I can use frequencies. It doesn't matter how you're gonna do it. So you can add up these numbers right here. Well, let's go ahead and use frequencies also. So what are the frequencies? I have 72 plus 19 plus 10. So 72 plus 19 plus 10 divide by 827. Okay, if you want to do this by hand, you can. So I'm going to do 72 plus 19 plus 10 divide by 827. 0.1221. Okay, so then the next 2 parts can be answered with the same calculator command. This one says compute the mean and the standard deviation. Okay, I know the book gives you these really complicated formulas. You don't have to do that. All you gotta do is go to stat, one variable statistics, and make sure you use L1 and L2. Okay, the first one will be the x values, and the second one will be the probabilities associated with each of the values. And there you have it. So x bar is 1.58, right? X bar is, well, okay, let me see the notation. It'll be here, mu of x is 1.58, and the standard deviation, let's take a look at it, 0.875, let's call it that, 0.875. Okay, that's it. That answers your questions. So what are these probabilities? Okay, so my mean, standard deviation, okay, this one right here, and these are your answers. All right, so that's basically it for this first section. Okay, discrete random variable. All right, so one command here to remember, right? So let's go ahead and write it out. The command that you need to remember: one variable statistics L1 comma L2. Now they don't necessarily have to be L1 and L2. They can be anything you want, as long as this is where x values are stored and this is where the probabilities are stored. Okay, not frequencies, probabilities. Okay, so little numbers, small numbers, the ones that are between 0 and 1. Okay, let's take a look at the next section. What was the next section? Binomial. And for this section, I would like to go to page 217. Okay, so let's see, 217, that's where we're going. Okay, and we're gonna take a look at problem 30. So let's see what we have here. All right, car inspections. Of all the registered automobiles in Colorado, 8% fail the state emissions test. Okay, and 12 of the cars are selected at random to undergo an emission test. All right, so binomial distribution. None of these problems will actually tell you, oh, by the way, this is a binomial. How do we know? How do we know that this is the one that we need to be using? Okay, well, there's a couple of things that we need to remember here. Let's see, the outcome. Only 2 possible outcomes of a single experiment. So for our problem, let's take a look at this problem. The car that is selected is either going to fail or pass the emission test, right? So those are the only 2 things that can happen. Okay, so for us, it's going to be pass, fail the emission test. Let's see, how do we spell emission? 2 S's? Yeah, 2 S's, okay. Emission test. All right, so only 2 possible outcomes. Let's see, what else do we have? We have finite number of trials. Okay, and what is it going to be for us in this problem right here? 12 cars are selected. 12. Not as many as we need to until we get, let's say, 5 cars that fail. No, exactly 12, regardless of what the outcome is, right? So 12 cars, we say n is equal to 12. Okay, let's see. Trials are independent. And this will be usually satisfied, but let's just think about it. Well, these 12 cars are selected at random. It's very unlikely that, all 12 of them will be, let's say, in the same family or even same neighborhood. So it makes sense to assume that these are all independent cars, okay? And then the probability should be in the same probability, same P for all trials. Okay, and this one is also typically true. So really what you need to think about is, are there only 2 possible outcomes, and do I have a finite number of trials? Also, what is this P? In our case, our P is, let's take a look at what the problem says, 8%. So probability of success, and I know in this case it's not exactly the good thing, is 0.08. Okay, so success in this case is something that will the outcome that we're looking for. Okay, the outcome that we are looking for or we're expecting. Okay, not necessarily a good thing or positive thing. In this case it's actually bad. If your car fails the emission test, it's not exactly a good thing. Okay, so let's see, I have all of these satisfied, so I know this is a binomial distribution. I'm gonna go ahead and write out everything that I have. I have 12 cars that are selected. Probability of success is 0.08. So X is the number of cars that fail the test, right, out of those 12. Okay, so let's see what this problem is asking us. Find the probability that exactly 3 of them fail the test. Okay, Okay, I'm going to do probability that exactly 3 fail the test. Binomial PDF. Okay, this is important. Oops, that's not what I wanted to do. Binomial PDF. Whenever you have equality, write PDF. That's the command they're going to be using. All right, so, and I'm going to plug in number of trials first. That's 12 trials. Probability of success is 0.08, and I'm looking for 3 cars to fail. Let me just double check. Is that right? Exactly 3. Okay, so how do I do that? We're gonna go to second variables. I'm gonna turn it on first. Second variables, binomial PDF. Okay, and plug it in just like that. So we have 12 cars that are picked. Probability of success for 1 is 0.8. Exactly 3 cars that fail. Here's my answer, 0.0532. Okay, 0.0532. Okay, let's take a look at the next part. Find the probability that fewer than 3 of them fail the test. Less than 3, right? So let me write it out. Probability that less than 3. Less than 3 means 0, 1, and 2. Now, whenever I have an equality going this way, I'm going to be using binomial CDF. Okay, so whenever you have an inequality, oops, why is this doing strange things? Okay, going this way, we're going to be using CDF. CDF stands for cumulative. It's adding numbers up for you. Think about this way. I'm going to add up all of the probabilities. If I pick 12 cars with this probability of success, less than 3, that means 0, 1, and 2. So I need to add up to 2. Okay, not 3, because then it will be adding probabilities of 0 successes, 1, 2, and 3 successes. But we have less than 3, so we're going up to 2. Okay, I'm going to go to second variables and binomial CDF. C stands for cumulative addition, so we're going to do 12.08 up to 2. 0.9348. Was there a 0? Nope. 9348. Okay. All right. Let's keep going. Find the probability that more than 2 of them fail the test. More than 2. More than 2. Okay. Let's see. Probability that x is more than 2. What does that mean? It really means 3, 4, 5, 6, and so forth, up to 12. Maybe all 12 of them will fail. Okay, whenever you have an equality going this way, we need to use the complement rule, because your calculator cannot compute from non-zero to another non-zero number. It can only compute probabilities from x is equal to 0 to x some number. So we're going to be doing 1 minus binomial CDF 12.082. Okay, that's your complement rule. All right, so we actually have it computed, right? So let me just highlight this part right here. Oops, I don't need that. Okay, if it's going this way, you got to be using 1 minus the opposite. Okay, so we have this answer right here, so it will be 1 minus this, but let me show you how you would plug it in. Just like that in your calculator, you would do 1 minus binomial CDF. Let's see, where are we? Right here, and we're gonna do 12.08 and up to 2, right? Okay, 0.065 0.0652. 0.0652. Oop. Okay, and look, if you add up these two, what's gonna happen? You're gonna get exactly 1, and that makes sense. Okay, one more part here. Would it be unusual for none of them to fail the test? What does it mean? None of them. X is equal to 0. Probability that X is equal to 0. Exactly a number. That's PDF 12.080. Let's compute it. Second, variables. Binomial PDF. I have 12 trials. 0.08 and 0. 0.3677. Oh, I keep picking this one. 0.3677. Okay, that's your answer here. So would that be unusual? The answer is no, because 0.3677 is greater than 0.05, right? Our cutoff is 5% or probability of 0.05. All right, so that's how you would solve this problem. The only other thing that we need to remember is you might be asked to find the mean and the standard deviation of the binomial variable. So the mean would be computed by n times p, and then the standard deviation is computed by square root of n times p minus, not p minus 1 minus p. Sorry about that. You might get a negative number here. Well, actually, you guaranteed to get a negative number, right? So 1 minus p over here. Okay, so just put these formulas on your formula sheet. You don't need to memorize them. Oh, they're not too difficult. You can also memorize them if you would like. But I think that's basically it. That's everything that you need to know for chapter 5. So let's go back again. Random variable. Know how to construct a probability distribution function. Use your calculator. So the main calculator command here is variable statistics to compute your mean and standard deviation. And then binomial, know how to recognize that this is a binomial experiment, and then get your notation right away. What is your n? What is your p? And you have two commands here, binomial PDF, binomial CDF, and then how to compute the mean and the standard deviation. All right, thank you for watching.